As we begin chapter 10, 10 covers graphing quadratic functions. And so we'll learn several ways to graph a quadratic function. But we are going to begin with the most basic way, which is to make a table. So let's define what a quadratic function is first. It's any equation that can be written in the form y equals ax squared plus bx plus c. And when we graph a quadratic function, we will always get what's called a parabola. And some parabolas will open up, and they will have a very small value down here, which is a minimum. Some parabolas will open down, and they'll have a large value here, which is a maximum. And we'll talk about how we know when it opens up, when it opens down. Also, something to note about parabolas, which is what the rest of the chapter will be based on. When you have a coordinate grid, sometimes the parabola will cross over the coordinate or the x-axis in two places. Sometimes it will just touch in one place, and sometimes it won't touch at all. This will be really a large chunk of this chapter, finding the roots or the x-intercepts of these parabolas. So this one has two roots, or two x-intercepts, one root, or no roots. And it all just depends on each of the individual equations. So we're going to begin by making a table of values for each quadratic function when we're given the vertex, and we're going to graph the parabola. So here's our function. It's already in the form that we need it in, and here's the vertex. The vertex is always going to go in the middle of the table. So this is different from graphing a line, because when we graphed a line, we use -1, 0, 1, and 2 each time. In a parabola, you have to find the vertex, which is this point right here. It's the center. And then this is the vertex. And then we want the center point. We want the center point, and then we want to build a couple points on the left and a couple points on the right. So the vertex will always go in the middle, and then you're going to go up or down from there. So if we go down, we would get 0, and down we get -1. If we go up from 1, we get 2 and 3. So it's all about the vertex. That's the most important piece in a parabola. And then we build the table based on the x value in that vertex. Then, as with tables and everything else we've always done, we're just taking this x value and plugging it into this equation. And you have to show one step of work here. So I like to do some of the work. So x squared would be -1 squared, which gives me 1. And then I want to do -4 times -1. So it says -4x, but if I treat this as a -4 and I multiply that by -1, I get +4, and it's always going to be -5 because there's no variable in there. So 2 times 0 squared is 0. -4 times 0 would be plus nothing, -5. We already did this one. Well, it's already done for us, so we don't need to do it. Then we do 2 times 2 squared, which is 4. -4 times 2. 4 times 2 gives me 8. And then 2 times 3 squared, which is 9. And -4 times 3 would be -12 -5. So here we get 2 plus 4 is 6. 6 minus 5 is 1. 2 times nothing is 0. 0 plus 0 minus 5 would be -5. 2 times 4 is 8. 8 minus 8 drops out, and we get -5 again. And 2 times 9 is 18. 18 minus 12 is 6. 6 minus 5 gives me 1. You should recognize the pattern here. The vertex is in the center. Then these are both equal distance from the one going up and down, and these are both going to be -5. And then these two guys also should pair up at 1. So let's graph it. -1, 1, 0, and, oops, 0, 0, 5, negative 5, 1, negative 7, 2, negative 5, 3, 1. And when you graph your parabola, you want to make sure that it's round. It will never look like a V. You're always going to graph it so it's round at the bottom here. All right? So it makes sense that if this is the center of the parabola, and it's actually symmetrical on both sides, that whatever point we get here, we should get the same point here. And that's why you're noticing that pattern there. If you get the wrong vertex in the middle, then this pattern will not work. Let's try another one. Number 2 is a little trickier because we've got a negative sign in the front. The vertex is 2, 3. So this time you have to put that in the middle yourself. And we go down from there, 1, 0, and up, 3, 4. Now the key here is we've got a negative x squared plus 4x minus 1. And what you need to make sure that you understand is that with only that negative sign there, it really means negative 1x squared. All right? So it's important that you remember that, and probably the best way to remember is to actually put it in there. And we're going to do exactly the same thing we did. So this time it's negative 1 times x squared, negative 1 times 1 squared, negative 1 times 2 squared, negative 1 times 3 squared, negative 1 times 4 squared. And we still have to do the rest of this. 4 times 0 would be 0. 4 times 1 would be 4. 4 times 2 would be 8. 4 times 3 would be 12. 4 times 4 would be 16. And then all of these are minus 1. So we got 0 plus 0 minus 1. Negative 1 plus 4 is 3 minus 1 will give us 2. I really didn't have to do that one. Negative 1 times 9 is negative 9. Plus 12 would be 3. 3 minus 1 is 2. Negative 16 plus 16, those two cancel each other out, and we get negative 1. So when we graph this guy, 0, negative 1, 1, 2, 2, 3, 3, 2, 4, negative 1. Again, make sure you make it smooth. You want to draw your parabola to the edge of the graph, and it goes on forever. So just like a line, it should have arrows on both ends. So make sure to include that. Now, this opens up. So this is our vertex, and that's a minimum value because it's like a valley. That point is the very lowest point. That's the minimum. This is the vertex on this guy, and it's like a mountain. So that's the maximum or the highest value. So that's how you make a table of values. Now the thing is that you are not going to know the vertex, so you need to know how to find the vertex on your own. So the vertex has a formula. The vertex, for the first part of it. Now remember, the vertex is a point with an x and a y, so we need to know how to find the x, and then we can find the y by plugging the x in like we did for all the table values on the front. So the vertex is this, x equals negative b over 2a. So we've got to identify the parts, and then the vertex is also the maximum or the minimum value in the parabola. Like we talked about that on the front. So if we want to find the vertex of this function, we need to know a, b, and c are first. So a, b, c. A is the number. Remember, it's y equals ax squared plus bx plus c. So a, b, and c are these numbers. So if there's no number here, it's understood to be 1. This is positive 4, and this is negative 9. So if we're doing negative b over 2a, we're doing negative 4 over 2 times a, which is 2. And that's my x value, which is negative 2. That is the x value in your vertex, so that's going to go here, and then we build up and down from there. So if I go down, negative 3, negative 4, if I go up, I get this. And so we can find the y value here for the vertex, just like we found the y value in the other table points. So we've got, if you want, x squared would be 16, negative 3 squared would be 9, negative 2 squared would be 4, negative 1 squared would be 1, and 0 squared would be 0. And we got 4 times each of these. 4 times negative 4 would be negative 16. 4 times negative 3 is negative 12. 4 times negative 2 is negative 8. 4 times negative 1 is negative 4. And 4 times 0 is 0. And then the negative 9 is the same every single time. I like to set up all the work first and then find all my answers. So 16 minus 16 minus 9, these drop out. 9 and negative 9, those will drop out. We get negative 12. 4 minus 8 would be negative 4. Negative 4 minus 9 would be negative 13. 1 minus 4 minus 9 is negative 12. These drop out, of course, and we get negative 9. Notice the pattern, negative 12, negative 12, negative 9, negative 9. That kind of confirms that you did it right. Now, you are required to show work, one step of work for each of these, so you can't skip these guys and then copy that answer down there. Because if you made a mistake up here and then you copy it down here, now you've made 2 mistakes. That wouldn't be good. All right, this one looks a little shorter. If I extend this, it would look like this, ax squared plus 0x plus 6. So this one isn't missing the c term. The c term is always going to be the constant, the whole number. It's missing a plain old x. So if I write it in there so it makes a little more sense to you, I want you to find the vertex and then see if you can build a table and find the values, and then come back to it. All right, let's give it a shot. If you haven't tried it yet, push pause and try it. So we've got A is negative 1, B is 0, and C is 6. So x equals negative b over 2a, which would be negative 2, and 0 divided by anything is going to give us 0. So the x value in this parabola for the vertex is going to be 0. Build down from there, build up from there. If you haven't tried it on your own yet, pause here and try it on your own. So the first step is the opposite of x. So that would be 2, 1, 0, negative 1, negative 2. And then we add 6 to each of them. So 2 plus 6 is 8. 1 plus 6 is 7. 6. Oops, what did I do? Oh, I made a mistake. Oops, oops, oops. Let's back it up. I hope you didn't do that. I forgot the squared here when I copied it over here. So negative 2 squared would be 4. And then remember, we have like a negative 1 in front of this. I really messed up, sorry. Then negative 1 squared would be 1. We have a negative 1 in front of it. This one's going to be fine. And then here, 1 squared is 1, and we put a negative 1 in front of it. And 2 squared is 4. I'm sorry about that. All right, so I just forgot to square it when I copied it over here. So we have to square each number, then multiply it by a negative 1 because of that negative sign. Be very careful there. All right, let's try this again. This one's still 6, but this is negative 4 plus 6 would give us 2. Negative 1 plus 6 gives us 5. Negative 1 times 1 would be negative 1 plus 6 again would be 5. And this is going to give us negative 4 plus 6, which will give us 2 again, much better. The 5's pair up, the 2's pair up. Don't make that mistake.